tutorial in Blender on how to make a procedural niche shader for 3D fashion design. The shader will allow us to change and control the overall appearance of the niche stitching. So we will have column spacing, individual stitch spacing in the X direction, and then the stitch spacing in the Y direction, which is basically also row spacing. Then the stitch angle. So when you increase the stitch in the Y spacing, then you can accommodate for that with the length of the stitch. And also the stitching angle, because if you go more than that, you need to change also the angle. Then you of course can change the width of the stitch. The edge roundness of the stitching. You see it when we make some spacing. Then the ply of the yarn. This is how dense the twisting is of the thread, and the angle of that. Then the hairiness, how much little hairs the yarn has, and the overall flexibility. To simulate the deformation of the knit in different circumstances, and of course the scale. Then we can have, if you apply some image texture on the knit, then it's basically like it's printed on. It's like printing on it. But there's also this jacquard option. This means that it's like the process of making patterns actually while the stitching takes place. So this is a real yarn that is in color black. If we scale it, we can see this effect better. Alright, let's get started. So we have created a plane with a new material on it. We can delete this one and add UV coordinates and connect them to the surface output. So we have here a UV space. So this point is 0, 0. We need to shift this to the center of this plane. We will do that by adding a vector math node and shift the whole coordinates UV space for -0.5. So you see it's on the middle of the plane. Next, we can separate the x-axis and the y-axis and work on them separately. So we are going to do separate x, y, z, and as you can see, we have now the x-axis, so positive integers, negative integers. Blender is representing every negative integer as black, and as you can see, you have here a gradient rising up. We are going to scale this now up a bit by adding vector mass scale node right before the adding here. And now we are making some repeating pattern which will actually be each column of the knit stitch. And we will do that by adding a wrap node and changing the maximum and minimum values. We are basically telling Blender to output values between the minimum value and between the maximum value. So you see it's outputting from 0 to 0.5 and it's repeating again. If we scale it even more, we have more columns. Let me make some better overview of the setup till now so you can follow better, because I know that for beginners it's kind of hard to find the right nodes in time. So we make some space here more. The next one, what we need to do is we need to make each column symmetric, which basically means that we want, for example, that the zero values also get here, so that in the middle of this column the values are maximum and that they are going again down till here to 0. We're going to do that by applying absolute values, which means that everything what is on the left of this 0 value here, so the negative integers, they need to get positive. So when we apply now a converter mass node absolute value, this is actually being done by Blender, but we cannot see that because it's hidden behind each column on the left, to the left side, which means we need to move each column to the right, and we are doing that by adding, actually subtracting 0.5. Alright, so you can see that in kind of slow motion how this is actually manifesting here. The next thing we're going to do is to control these black values in between, because each column of these positive values are going to be threads for the knit stitches. So we are going to subtract some values here in order to get more black space in between. So now what we need to do is to separate this pattern also in the horizontal direction, right? Because each box then will actually represent one of the knit stitchings. So we need this y-axis here. We copy this wrap node again and input it in the y-axis into the value, and if we combine the x and the y-axis again, we actually get a modified new coordinate system which looks like this. What we are going to do now is that we are going to separate it again. So copy this one and add it into this socket, and we get working again on the x-axis. Now we are going to make the most important trick, which is making actually this shader possible, which makes it actually so nice in terms of making so much controls possible. So we make some space here, and now we add a vector mapping node. And if we now rotate the Z rotation here, you can see that we are getting some kind of a V shape, which will be our knit pattern, right? To get this kind of V-looking thread shape of our knit stitches, we are going to do the same trick as here. We are again converting these negative values to positive ones, and we are again getting here this nice middle line of 0 values. So let's do that. Copy this absolute node and put it into the x-axis here, and as you can see, it actually happened. And we just now need to invert these values, which is pretty easy. We are just going to subtract them. As you can see, we arrived at our V-shaped knits, but now the top and the bottom, these are sharp cuts, and we need to also smooth that out. And as you have guessed it, we are doing again something similar as here. We need to combine the x-axis again with the y-axis, which will smooth these corners. Before that, I can give you a quick overview of what we have so far, so you can check if you have done everything alright till now. So in order to smooth the top and the bottom, we are going to use the y-axis for that. A smooth minimum node. So you go to converter math again and choose smooth minimum. And now you combine the x and y axis. So we are not using this one, but this one. We can see what we have so far. You see here some smoothing is taking place, and this is because of these negative values here. But first of all, why do we have this kind of a subtle triangle gradient anyway? Because of course of this rotation here. And if you take a look at y-axis here, it's not kind of triangle, right? Because this is taking place after this node here. So if this goes through that node, it's getting this triangle shape, right? And if we combine this one with this one with a smooth minimum node, then it's actually taking into account the negative values of the y-axis in combination with the x-axis. So it smoothens out the x-axis in relation with the negative values of the y-axis here. But we need also to smooth out the top value. If you look at y value, we got this negative part only on the bottom, and So we need to have